China's been advancing its prefabricated building industry. A 50-meter-high super factory for prefabricated parts is set to open in South China's Shenzhen.
China is famous for speed, scale, and advanced engineering across cities, transport, and energy. As other nations plan upgrades and review proposals, China is constructing 8 massive systems in 2026 that may reshape global trade and travel. How are they connected? What do they mean for the future? Join us as we explore these massive buildings and the reason behind them. Number 8. Guangzhou's Future Air Kingdom. China is transforming its aviation landscape with massive airport projects. One of the most striking examples is the expansion at Guangzhou Baiyun International Airport. Over the past several years, this airport has undergone a dramatic upgrade. The most recent phase added a brand new Terminal 3 and a 5th runway, turning it into a much larger and more capable hub for passengers and cargo. Before this expansion, the airport already served tens of millions of people each year. With the new terminal and runway, it has become one of the busiest airports in China and one of the busiest in the world. The goal is to handle up to 120 million passengers annually and move nearly 4 million tons of cargo and mail each year. With future build-outs, that capacity is expected to rise even higher. What makes this project remarkable is how it brings all forms of transport together. High-speed rail lines connect directly to the airport, linking it by rail to other major cities in the region. Metro lines, expressways, and intercity railways are all designed to meet at the aviation hub. This means people can travel between planes and trains without confusion or delay. The integrated transport center makes it simpler and faster for passengers to switch from rail to air. Inside the airport, smart systems help make travel smoother. While details vary, planning has included technologies to manage baggage more effectively and to schedule flights and gates in ways that reduce waiting times. These systems help keep passengers moving efficiently through check-in, security, and boarding. Cargo operations have also been boosted with the expansion. With additional runways and more terminal space, the airport can handle significantly more goods. This is crucial in a region where manufacturing output is high and exports need fast connections to global markets. The expanded cargo facilities strengthen supply chains and improve logistics for businesses that rely on air freight. Yet some of China's airports aren't built on land at all. They're built on the sea. Number 7. Xiamen's ocean runways. China has limited flat land in many coastal cities, and rapid growth of aviation demand has pushed planners to think creatively. In places like Xiamen and other coastal regions, airport projects have expanded runways and facilities into reclaimed land or close to the sea to maximize space. This means building on coastal extensions or near the shoreline rather than far inland. This approach helps cities handle more flights and larger aircraft without being constrained by nearby mountains or dense urban areas. The key behind building airports on or near water is simply geography and necessity. Coastal cities often lie on busy trade routes and have booming populations. Aviation demand grows as business travel, tourism, and cargo flows increase. To meet that demand, planners design runways and terminals in areas where land is scarce. Some coastal projects include artificial islands, reclaimed land, and engineered coastal platforms that support runways and service areas. These structures are connected by bridges or causeways to the mainland. Urban planning context based on general aviation expansion trends. The engineering behind water-adjacent airports is demanding. Builders have to ensure stability against tides, waves, and corrosion from saltwater. Deep foundations and protective seawalls are standard. Drainage systems prevent flooding, and careful surveying makes sure runways stay level and safe for heavy aircraft. This kind of work uses modern materials and construction techniques to make airports reliable, even in challenging marine environments. Air travel is fast, but China is building something on rails that might make flying unnecessary. Number 6. The CR450 revolution. China is on the brink of changing how people travel long distances. In the world of rails, one new train stands above the rest. This is the CR450 high-speed train, a machine designed to travel at astonishing levels of speed for a conventional train. It is expected to begin regular service around 2026. Its design speed is 400 kilometers per hour during normal service, with test runs showing it can reach 450 kilometers per hour under certain conditions. The CR450 is the fastest high-speed train in the world for regular rail service. It pushes beyond existing high-speed models that travel at around 350 kilometers per hour, setting a new standard for speed and efficiency on steel rails. One of the reasons the CR450 can go so fast is its shape. The front of the train is long and narrow, cut like a blade through air. This sleek nose and aerodynamic body reduce wind resistance, so the train uses less energy as it speeds forward. Lightweight materials, such as carbon fiber composites and advanced alloys, are used in its body. These materials make the train lighter without sacrificing strength. The result is a powerful train that cuts through air with reduced drag. Another key element of the CR450's design is its propulsion system. Instead of traditional motors, it uses permanent magnet traction motors that can convert electrical power into movement very efficiently. This type of traction system helps the train accelerate quickly and maintain high speeds while using energy wisely. Stopping such a fast train safely is just as important as moving it quickly. The engineering team designed advanced braking systems to ensure stability and safety even at top velocity. Emergency braking systems work across multiple levels to help the train slow down smoothly and securely when needed. Even though the CR450 travels at incredible speeds, it is also built for comfort. The train's cabin is quieter and more refined than before, thanks to improvements in noise reduction technology. Interior space has been increased slightly, giving passengers more room and making the trip more pleasant. Sensors across the train constantly monitor critical systems in real time. More than 4,000 sensors track details like pressure, temperature, and movement. If something changes unexpectedly, the system alerts operators so they can act quickly. These monitoring systems make travel safer and more reliable. But what happens when trains must run where even humans struggle to breathe? Number 5. Tibetan Plateau High-Speed Line. China has built one of the most remarkable railways on Earth, across the Tibetan Plateau. This is a place where the air is thin, the ground is frozen much of the year, and the landscape seems to touch the sky. The railway stands as a real engineering landmark, connecting remote regions to the rest of the country. The most famous high-altitude rail link is the Qinghai-Tibet Railway. It stretches nearly 2,000 kilometers from Xining in Qinghai province to Lhasa in Tibet. Along the way, the track rises above 4,000 meters in altitude for most of its length. The highest point of the journey approaches 5,000 meters above sea level, making this the highest long-distance rail line in the world. At such heights, the air has far less oxygen than at sea level. That makes breathing harder for people not used to thin air. To help passengers stay comfortable, trains on this line have special oxygen systems that slowly release oxygen into the cabins. These systems help reduce the effects of altitude sickness for travelers moving through the high plateau. The ground beneath the track posed its own challenge. Far more than half of the rail bed sits on permafrost, frozen earth that can shift with temperature changes. If the frozen ground melts, tracks can warp or buckle. To prevent this, engineers built long sections of elevated track on deep foundations. They used cooling pipes and ventilation techniques to keep the ground cold and stable under the rails. Another extreme part of the line is the tunnels and bridges spread across the mountain. There are hundreds of bridges and dozens of tunnels on the route. Some tunnels go deep under high passes, and some bridges rise above wide valleys. Each structure was planned so that the railway could cross the rugged terrain with smooth curves and safe grades. The thin air and harsh cold also affected workers during construction. Builders preparing the route needed special support to deal with oxygen shortages and freezing temperatures. Work was done carefully to protect both people and the fragile environment on the plateau. Because of the extreme environment, trains on this route travel at moderate speeds compared with flatland rail lines. Typical running speeds are around 100 to 120 kilometers per hour on the main high-altitude section. Even at these speeds, the trip is smooth and reliable, thanks to careful design of track and roadbed. Moving people is impressive, but China's real power move is how it moves electricity across thousands of miles. Number 4. Solar and wind megabases. China's renewable energy transformation is one of the most significant changes happening in the world today. Across vast arid regions of western China, especially deserts like the Gobi and others, huge areas of land are now being used to generate clean electricity. These areas, once seen as empty and unproductive, are becoming the backbone of China's energy future. In places like Xinjiang, Inner Mongolia, and Qinghai province, China has begun building some of the largest renewable energy bases on the planet. These installations include solar photovoltaic panels that capture sunlight and wind turbines that harness strong desert winds. Together, they produce enormous amounts of electricity. One large transmission base in Xinjiang, at the foot of the Tian Shan Mountains, has begun sending power across the country with more than 14 million kilowatts of capacity. Most of this energy comes from wind and solar sources. These desert renewable zones are part of a broader national strategy to build energy where the sun shines longest and the winds blow most consistently. By 2030, China plans to have tens of thousands of megawatts of renewable power capacity in these areas. One example under construction in the Kubuki Desert of Inner Mongolia includes 8 gigawatts of solar, 4 gigawatts of wind, and 5 gigawatt-hours of energy storage. This project will link to ultra-high voltage power lines that carry electricity nearly 700 kilometers to cities in northern China. The scale is enormous. China's goal for desert wind and solar capacity alone is expected to approach 455 million kilowatts by 2030, according to government planning. These power bases are engineered to sit alongside thermal power and grid storage that help balance supply when renewable generation fluctuates. Ultra-high voltage transmission technology plays an essential role in connecting these remote power zones to the cities and factories that use electricity. China has built and is expanding what are effectively expressways for power, moving energy efficiently across huge distances with minimal loss. Some high-voltage direct current lines stretch hundreds or even thousands of kilometers. One such line is designed to carry power generated in Western renewable bases to major cities in the eastern provinces, delivering billions of kilowatt-hours annually. The massive scale of wind and solar installation is supported by a network of storage systems. These include batteries and other storage technologies that hold excess energy when production is high, so that electricity remains available when generation drops, such as at night or during calm weather. This storage capability is vital because renewable sources like solar and wind do not produce a constant output by themselves. But renewable energy is only half the story. China is also betting on something much smaller and far more shocking. Number 3. Linglong 1 SMR. China is building a new kind of nuclear power plant that changes the way nuclear energy has been done for decades. This project is called Linglong 1, and it is the world's first commercial onshore small modular reactor. Unlike traditional giant nuclear stations, this reactor is designed to be smaller, modular, and more flexible, making it easier to build and use in many places that once could not host a nuclear plant. At its core, the Linglong 1 is a small, modular, pressurized water reactor with a capacity of about 125 megawatts. That means it can produce enough electricity for hundreds of thousands of homes once completed and connected to the grid. The project is being built at the Changjiang nuclear power site on Hainan Island in southern China. What makes this reactor special is how it is manufactured and assembled. Instead of building every part piece by piece at the construction site, many critical components are prefabricated in factories. These pieces are built to precise standards and then brought to the site to be fitted together like sturdy building blocks. This modular approach helps reduce construction time, lowers the chance of mistakes, and saves money compared with traditional nuclear builds. The heart of the reactor, where the nuclear reactions occur, is integrated into a single unit before it leaves the factory. This integrated core includes the pressure vessel, steam generators, and main pump systems all ready as one piece. Because so much of the complex work is done in controlled factory conditions, the final installation at the site goes smoothly and quickly. Safety is a central part of the Linglong 1 design. The reactor uses passive safety systems, which means that it relies on natural forces like gravity and convection to keep it cool if something goes wrong. If electrical systems fail, water naturally absorbs heat and prevents overheating without human intervention. This reduces the risk of accidents and makes the reactor inherently safer. The Linglong 1 has also passed important international safety reviews, including approval from the International Atomic Energy Agency. This review shows that the design meets strict global safety expectations and can be trusted to operate reliably when connected to an energy grid. Beyond electricity generation, this type of reactor can be used in many ways. It can provide heat for towns and industries, support industrial steam production, and even help with desalinating seawater for regions that struggle with fresh water availability. These multiple uses make small modular reactors versatile energy sources for a wide range of settings. Once fully operational, Linglong 1 is expected to produce nearly 1 billion kilowatt-hours of electricity per year. This clean energy output can help reduce carbon dioxide emissions by hundreds of thousands of metric tons annually, contributing to regional and national goals for cleaner power and lower environmental impact. Yet even nuclear power needs water, and China is controlling rivers like never before. Number 2. Tiangong expansion. China's space station, called Tiangong, is already one of the most advanced human-made outposts in low Earth orbit, and it is expected to grow significantly in the coming years. Unlike older space stations that were built all at once, Tiangong was designed for modular expansion, allowing new sections to be added over time. Currently, the station consists of 3 core modules. The central module known as Tianhe, which provides life support, navigation, and control functions, and 2 laboratory modules called Wentian and Mengtian. These modules are arranged in a T-shaped design that allows spacecraft to dock and crews to move easily between them. Although the station already supports long-duration missions with crews living and working aboard for months, China plans to expand Tiangong even further. Space engineers have proposed adding additional modules in the coming years, which could roughly double the current outpost size and increase its research and living space. These new sections are planned to connect via docking ports built into the existing structure. Expansion plans focus on the creation of a cross-shaped configuration, where new modules extend outward from the core. This layout will make room for more laboratories, additional living quarters, and areas dedicated to specific types of scientific research. These expansions will allow astronauts to conduct experiments in physics, biology, and materials science that cannot be done anywhere on Earth because microgravity affects the way matter behaves. One of the reasons Tiangong's expansion is important is that it keeps human space presence continuous even after the current International Space Station, ISS, built and managed jointly by several countries, is retired later this decade. Tiangong's extended lifetime may go well beyond that of the ISS, giving researchers a longer period to study space science directly from orbit. Tiangong supports both crewed and cargo spacecraft. Taikonauts, Chinese astronauts, travel aboard Shenzhou spacecraft that dock with the station, and cargo missions launch aboard Tianzhou spacecraft to deliver supplies, equipment, and scientific instruments. This support system allows missions to remain on station without interruption and keeps research going continuously. In addition to expansion, other technologies are being developed to support the station's long-term operation. These include next-generation spacecraft designed to ferry larger crews and advanced platforms capable of hosting experiments that pave the way for future deep space exploration and missions beyond low Earth orbit. Tiangong's growth also reflects China's commitment to building its own independent human spaceflight infrastructure. It began after China was not part of the International Space Station program and opted to create its own orbiting facility. Today, Tiangong serves both scientific and strategic goals, fostering domestic research and international space cooperation in the future. While astronauts build in zero gravity, engineers back on Earth are building the biggest transport hub you've never heard of. Number 1. Xi'an East. Xi'an East Railway Station is one of China's biggest new transport hubs under construction in the city of Xi'an in northwest China. This station is not just another stop on the map. It is being built as a major integrated hub that will link many important rail lines and serve tens of millions of passengers every year. The main structure of the station was completed recently, and final work is underway before it opens for full service. The station sits in the Baqiao district and is part of a broader plan to strengthen Xi'an's role as a key inland transport center. It is located on land that once hosted a smaller station, but new construction has transformed the space into something far larger. This hub will handle both high-speed rail services and conventional rail lines, along with city transit systems like buses and metro rail connections. Xi'an East Railway Station covers a massive area of around 394,000 square meters, with the main station building occupying about 100,000 square meters of that space. The complex includes multiple levels for arrivals, departures, waiting areas, and access to platforms. Once fully operational, the station is expected to handle about 36.5 million passengers every year, making it one of the busiest railway hubs in western and central China. The station is being developed to link several major rail corridors. High-speed routes will connect Xi'an East to cities such as Chongqing and Xi'an, while conventional rail lines will continue to serve regional travel needs. These connections will cut travel times significantly for people moving across central and western China, offering a reliable alternative to road transport and short-haul flights. One remarkable feature of Xi'an East is how many platforms and tracks it will include once finished. The station complex will contain 13 platforms, serving 27 tracks, allowing many trains to arrive and depart at the same time. This design helps prevent delays and keeps the flow of trains smooth even during peak travel times. The interior space of the station is designed to manage large volumes of passengers efficiently. Spacious waiting halls and broad corridors allow people to move easily between sections of the station without crowding. There are also mezzanine levels and clear signage to help travelers find their platforms quickly. The building uses structural and environmental design elements to help reduce energy use for lighting and cooling, including natural light and ventilation where possible. Xi'an East will also connect with several metro lines, including lines 5, 12, 15, and 21 of the Xi'an metro system. These rail connections make it easy for passengers to transfer between high-speed, long-distance trains and local transit services. Bus terminals and highway access points are integrated at the station's perimeter, providing even more options for onward travel. Around the station, new commercial and urban development is also underway. This will include retail spaces, offices, and service areas that take advantage of the steady flow of travelers passing through each day. Over time, these developments are expected to transform the eastern part of Xi'an into a bustling economic and cultural center. Stations like Xi'an East are part of China's larger strategy to build seamless transport networks that give people and goods fast, dependable connections across huge distances. Instead of long waits or indirect travel routes, passengers will be able to transfer quickly between trains or switch to city transit in moments. This kind of integration reshapes how people think about movement in inland regions, turning once distant areas into interconnected hubs of activity and commerce. By creating so many connections in one place, Xi'an East Railway Station will help anchor economic growth in the region. Towns and cities along its linked rail lines will find it easier to attract investment and workers. Industries that depend on moving large numbers of people or products quickly will benefit, and residents will enjoy faster, more affordable travel options for long-distance journeys. All these projects are connected by something invisible that most people never think about: data. If you enjoyed this video, like and subscribe, and also click the next video shown on your screen.